Hello, guys. Can you hear me, guys? Hello? Can you hear me, guys?
Hello, I can hear you.
Good.
Can you hear me?
Good. Yes, sir.
Okay.
So, I want to welcome every one of us to the course today. I'm Destiny Otto, and yeah, we apologize for the little delay we had. Yeah, so we are very much set for today's course, and it's going to really be very interesting. So I'm expecting that you will you gain a lot from this course. That you give it the best attention you can, and you at the end of the day benefit a lot. So just a few things to know before we go on. So this course is organized by Petrotechnical Hub. Some of you previously know us as Petroleum Students Hub. So we bring high quality training, high quality and high technical training your way in different areas of petroleum engineering software and data science and analytics applications in petroleum engineering, and not just petroleum engineering, geosciences too. So you might want to follow us on LinkedIn, on Facebook, on WhatsApp or Telegram, yeah, just to stay updated and to keep in touch with what we are doing, yeah, with our programs. So many of our programs are free, and we are very much open and available for business at all times. So different courses we offer, we hold different training courses from integrated production modeling, Prosper, Gap, MBAL, and then to Eclipse, to Petrel, to most of the popular softwares you know of, or commercially available softwares you know of. We offer training in these courses, in those areas. So including geoscience courses, right? So you want to watch out, particularly from next year, you will see a lot of trainings. So endeavor to keep in touch. If you have not joined our Telegram group, and endeavor to join the group. So we are glad to have every one of you here, and I'm still expecting a lot more to join us. So please, I plead with you to give your full attention. And then for this course will last 2 days, that is today and tomorrow. And yeah, and of course, you know, it's free, but if you need a certificate, you have to pay just $5, only $5. Unfortunately, today is going to be the deadline. By 23:59 hours tonight will be the deadline. That's on GMT. So GMT plus 0. So if you have not made your payments, you might want to do well to quickly make your payments, and yeah, and secure your space, right? So if you've got any questions or any other issues about the course, I would just love to hear it right now. I'll just take 2 questions, just to make sure it's interactive. And before we bring up our instructor today, just 2 questions only about the course. But in the meantime, you should know that you have to complete the assignment we'll give to you before we can give you a certificate, right? It's going to be a simple one, but you have to complete. You have to do something. We'll not just give you a certificate for watching the webinar. We need to be sure at least you can you can practice the little you have learned, right? So if you have a question, you can just signify by raising your hand. Yunanda, are you there?
Yes, I'm here.
Okay. So check the chat box. If I have a question, please just read it out quickly. Yeah. So does anyone have a question? Please use the chat box, or use the chat box quickly. Send in your questions about the course before the instructor comes up. Okay, Yunanda, please go on.
Yes.
Yeah. Do I have questions in the chat box?
Yeah, someone is asking, please, sir, will the Eclipse will be given to X?
Okay. if you check it, a version of the software have already been shared in the group. But you know, there are a lot of, you know, the software is not free. Yeah, the company doesn't give it free of charge. So it's if you have, it's better if you have from your company or from your school. You just go ahead with try to use the one you have in your company or your school to follow. But if you can't, there's a version that have been shared in the WhatsApp group. So you can if you're in if you're in any of our WhatsApp group, you certainly would have gotten it. So check out with the WhatsApp group. If you have not joined, maybe during the session we'll share the link in the comment section here for you to join the WhatsApp group.
Yes, there is only one question so far
Okay.
yet.
Okay, guys. So today is going to be great. So we are going to welcome our instructor for today, Engineer Joseph Oguche. Engineer Joseph Oguche is currently is a reservoir engineer currently with Halliburton. So you can you just know what to expect, right? So sir, you are highly welcomed.
Thank you, Dustin. Thank you.
So over to you, sir.
Okay, thank you, Dustin. Thank you once again. Hello, everyone. Can you all hear me? Can everyone hear me?
Yes, I can hear you, sir.
Okay. So Destiny can hear me. I want to assume that everyone else can hear me. So this is good afternoon from Lagos, Nigeria. I understand that a couple of persons are joining this meeting from a few other countries. And I don't know what time you are there, but I send my greetings. Okay, so I don't think we have so much time to waste. Okay, sound is not clear. Is it like Destiny? Is my sound clear?
From your end is clear. Yunanda, confirm that the sound is clear from your end.
Yes, the sound is clear here.
All right. So you might want to adjust your network or something to ensure that you are.
So some persons confirmed that okay. So someone says the sound is fine.
Yeah.
All right. So we don't have so much time to waste. I mean, we are talking about a reservoir simulation class, and we have just 2 days. As a matter of fact, we have and 2 days. It's just a few. The topic of reservoir simulation is that I don't think we can possibly cover the whole subject in 2 days. Okay, as fast as we can. And I also understand that we might need to focus more on the use of the software. And in this case, we are talking about Eclipse. All right. So how many of us has the software installed on our computers already? Because I am going to propose that the meeting is a hands-on practical session, right?
Yes, sir.
And for you to be able to follow perfectly, I mean, you just need to have the software installed on your computer. So just one person Destiny,
Yes,
please.
sir.
We have about 60 persons here in this meeting. Can you confirm how many? I mean, what fraction, an approximate number of people that have the software installed?
Okay, please, if you have the software, just quickly signify in the group chats, please. If you have the software, please. Okay. I've got 5 persons so far. 1, 2, 3, 4, 5. Yeah. So okay. The ratio of yes to no, it's a bit good. So we have 6 persons to 2 persons saying 6 persons saying I have, and 2 persons saying I don't. Okay, we have some persons saying no, I don't. Okay, the ratio is now 7 to 4.
Okay. Okay. So if that's the case, maybe we should just maybe I should just walk through. Oh, okay. Maybe I should just walk through the process and everyone gets to listen. Just try and listen attentively. If you have any question, you ask. And sorry, Destiny, are you recording?
Yes, sir. Yes, sir.
Okay, that'll be fine. If you're recording, it should be fine.
Okay.
Okay, so I'll just walk through the process. I'll walk through how the software is used, the type of data you need, the areas you need to touch for you to build a simulation model. Okay. So if you have any question, just try and note it down. And if your question is like a short one, you can interrupt me, okay? But if it's a long question, you can just note it down till at the end of the class, then you can ask, all right? So if you are able to, let's say something okay? If you are able to catch whatever we are doing, then going back to do it by yourself should be the assignment that Destiny talked about earlier.
Exactly, sir.
Would that be fine?
Yes, it's perfect, sir.
Okay. All right. So that's how we are going to go about it. Okay. I also want to believe that you can all see my screen. Can you see what I'm sharing?
Yes, I can see it from my end, sir. You know, and that confirm that you
that
can.
means everyone else can see.
Okay, good. Good.
Okay. So since we can see it, I'll just go on from here. I don't want to put it in a presentation mode fully because I'll have to come in here, in between whatever I'm saying, all right? So I'll just leave it this way. And again, the slides are very few. I actually went back to one of the slides I had earlier, all right? I took this a similar webinar sometime earlier this year, although that one is a more detailed webinar, I think about 10-day training, and that we went all the way to history matching. But in this training, we'll not be talking about history matching, all right, because it's a little bit advanced. So we're going to talk about how to initialize a simulation model today. And then tomorrow we're going to learn how to add production wells, okay? Or should I call it prediction wells to your simulation model? Yeah, it may be a little bit basic, but the workflow is always. So basically what you're going to learn today will serve as a good foundation for you to take on if you have interest in reservoir simulation. All right. So again, there is no time, so we will not have the luxury of introducing ourselves. But I guess you all know me by now. My name is Joseph, which I'm a reservoir engineer. I would have loved to share a little bit of my background with you, but again, there's no time, so let's just go on. So we have these objectives stated here to teach you how to construct a dynamic reservoir model.
Are you there, sir?
Can you hear me?
Yes, go on, sir, please.
Oh, okay. I think at some point I lost connection.
Sorry,
What was the last thing you had me say?
Okay, so you were just on this slide. You were
Okay,
saying.
Okay. All right. So we're going to learn the workflow, and then if you have any question, you can ask me. For any special interest, you can send your correspondence to Destiny Auto. I mean, you'll be able to handle everything else from there. Okay, so this was the course content. We're going to talk about some of this in this training. We're going to talk about rock physics, the type of data you need to model what we call rock physics. The type of data you need to model your PVT, which is your reservoir fluid. And then we're going to talk about how to couple all of them together to initialize a simulation model, okay? Are you guys following?
Please use the chat. Let's get your feedback, right? Yeah.
Okay, all right, we're following, good. Okay, so here we have a couple of things we are going to talk about, like I mentioned earlier. And I have some data that I'm going to share with you. Since we have agreed, then everyone should listen, and then after the class, you can now go back to practice, and as your assignment, I'm going to delete the sharing of data. Are you all with me? Are we good?
Yeah,
Okay.
good to go, sir.
All right.
Yeah.
All right. Okay, so the model we're going to be talking about, this is a very simple picture of the model. It has been extracted from the Eclipse software, okay? Yeah, it's a very simple model, but it's good enough for training, all right? And the first thing you want to do when you want to perform a reservoir simulation study, or you want to build a simulation model is to, okay, can I repeat what? Someone is asking me to repeat. I don't know what to repeat, but
so please just go on.
I think that
just go on.
okay.
Yeah.
All right. Okay, so the first thing you want to do is to understand the reservoir. Okay, someone is saying he's not seeing my screen. Can everyone else see my screen, please? So that I don't want to. Okay, all right. All right, so the first thing you want to do is to understand your reservoir, the reservoir you are trying to study, you are trying to model. And that is where we talk about model descriptions. So what are the things you want to look at? There's something we call reservoir compartments. Yeah, compartments or regions in a reservoir. Normally, these regions or compartments in your reservoir are created from faults. Okay. Are we all petroleum engineering students here, or geoscience students, as the case may be? Is anybody that is not familiar with these terms, fault, reservoir, and all of that?
Okay, sir.
I'll assume that.
Okay, sir. Please.
Go on.
We are just assuming that they are familiar with this, sir. So, if anybody has anything, they can go read it up by themselves.
Okay. Someone is saying I am not understanding here. Okay. So I'll assume that everyone here, has one or two things to do with geosciences generally. So compartments are generally created by faults. Now, some other parameters, some other things can also create compartments in your reservoirs, but basically faults. So if you look at this model that we have on the screen, if you go from here all the way down, there is a major fault, all right? And this fault here has created like two compartments, okay? Two different compartments in this reservoir, in this model that we have on the screen. So when you pick up your model, the reservoir you're trying to study, you want to look out for those kind of stuff, okay? You want to check for the size, the thickness of your layers, and of course, the entire reservoir, okay? You want to check the quality of the sand. Talking about quality of the sand, you are talking about properties like the porosity, the permeability, the net to gross, and all of that, okay? Then you look at the water saturation distribution. Okay. So you want to look at the water saturation distribution in your model as well. Okay, we're going to talk more about all of this. And if it's a reservoir that has been in production, definitely you expect to find wells, producing wells or injection wells and all of that. You expect to find those information. So you have to look out for them. And in a case where you find any type of well, let's say production well, for instance, you want to see how long it has been in production, and you want to go on to look at the production history. But of course, that would be for a case of history matching as the case may be. But what we are going to talk about here, we don't have any production well. So you are going to be creating your own well, and that's going to be tomorrow, okay? So you want to check the model description and take all the possible notes. Then here I want to quickly, again, talk about the type of data set that you need. that are required to build a simulation model. So you need the grid, like we talked about in the previous slide, and the grid must have properties, petrophysical properties present. So most of the times you get that from a static model, okay? Normally, static models are built by geologists. So when they have built the static model, they give it to you, and then you extract all the information that you need from it, which includes the grid. But in some other cases, like what we are going to be talking today, what we are going to be talking about today, I am not going to provide you with any static model. Rather, I'll provide you with the grid properties that have been extracted, that have been exported from a static model. So you might not find a static model, but you're going to get the grid properties. You can take note of that somewhere, right? So in your grid properties, you'll be expecting to see, most importantly, porosity and permeability, okay? And of course, faults. So you need pressure data, which is engineering data, by the way. The pressure data can come in different forms, okay? You have your RFT data, you have MDT data, you have BHP survey. BHP means bottom hole pressure. So you have all of that information that tells you the pressure behavior in your reservoir. Sometimes you have a whole lot of data points. Sometimes you have very few. Sometimes you have just one pressure data, and where it is measured, I mean, the depth where the pressure has been measured in the reservoir, okay? So you want to take note of that. So maybe somewhere you should just write it, pressure data and pressure versus depth data. Then other type of data you need to build your simulation model, you have the core data. So the core data is where is what helps you to model what we call relative permeability, okay? Or saturation function, as the case may be. So let's just leave it at relative permeability. You have different methods you can use to model your relative permeability. You can model it from core data if you have. And in a case where you don't have core data, you can create the relative permeability from correlations. There are a couple of correlations, or basically mathematical functions that can help you to predict or determine the interactions that your reservoir fluid have with the rock, okay? That is with the grid. So we're going to be learning how to use correlation to create this relative permeability. Yeah, I talked about production data earlier and wells data, and we don't have them. So if you're talking about history matching simulation, of course, you want to ensure that you have the production data in place. But in this case, we don't need it. So it's not available. Then there's another data that you need, very important data, is fluid contact, okay? Basically, the fluid contact will tell you at what depth you have this or that type of fluid. Okay, we know that hydrocarbon reservoirs, you expect to find 3 different types of fluids, right? Oil, water, and gas, all right? And normally, the way it is arranged is that gas will be on top, and then you have your oil, and then at the base, you have water, okay?
Fue a ver corazón, una escalera.
Ah, se fue a una escalera.
Sí, ya lo voy a revisar.
Oh, sorry, sir.
Can you
Unmute. Yeah. Sorry about that, sir.
Okay, fine. Okay, fine. All right. So I was talking about fluid contact. So you want to look at your fluid contact depth, where you have your gas oil contact, where you have your oil water contact, or do you even have them at all? If you don't have gas in your reservoir, you're not going to find anything like oil water gas oil contact. So the only thing you probably see is your oil water contact. And then in the case where you don't have oil, like in the case of a gas reservoir, the only thing you're going to expect to find is O4. The only thing you're going to expect to find in such reservoir is a gas water contact. In fact, cases you don't see either OWC, that is oil water contact, or GOC, gas oil contact. Then you begin to hear other type of contact that they call gas down to. Okay, in a gas condensate reservoir, would there be a GOC? Is this person a petroleum engineer? Okay. All right, in a gas condensate reservoir,
Sir.
because you call it a gas condensate,
Hello, sir.
That's a gas. Yes, I can hear you.
Sorry, sir. Sir, please just allow me to be at the chat. I will contact you when you have a question, sir.
Oh, okay. Okay, so that I won't be distracted. Okay.
Yeah, so that you won't be distracted, sir.
That's fine. Okay, so let me just turn it down. So because you call it a gas condensate reservoir, that tells me that you have gas oil contact, gas oil contact. But the problem or the concern, or should I call it the challenge, when it comes to a condensate reservoir is that they usually have a very thin layer of oil. Okay, very thin layer of oil that in some kind of studies, especially in a case where you don't have good quality of data, it can be very confusing. It may become difficult to locate this contact that tells you that you have oil. Okay, but definitely that you have a gas condensate reservoir means you have gas. Okay, we're going to talk about fluid data. For fluid data, it can come in different forms, right? You can have it as a PVT report, which is the most common. And then in some cases where data is not so sufficient, you can have just point data. By point data, I refer to basic information about your fluids and the operating conditions. So in that case, you might have information such as the bubble point, pressure of the fluid, formation volume factor, dissolved gas, and so on, but you won't have the composition and a couple of other tests that must have been conducted in a PVT laboratory to describe the fluid in more detail. So you want to look out for a PVT lab report. And in a case where you don't have a PVT lab report, you should have this point data that I just talked about, that I just mentioned, okay? So these are basically the data that you need to build a basic reservoir simulation model. Okay. Sometimes it can be much more detailed than what we have here, but these are the basic ones. And then we're going to look at all of this, of course, apart from these two here. So we're going to look at all of this in this meeting, okay? And of course, when you load your grid data into your Eclipse software, there is some information that you also want to look out for, like the type of grid that you have. Of course, most of the time, this is what is going to be when you are bringing it from a static model, a static model. So you want to see the grid size, the number of cells in your x-axis, y, z-axis. You want to see the total number of cells you have. Now, you will be interested in knowing the total number of cells that you have in your model, because this goes on to determine or give you an estimate of how long you need to, how much time you need to run the simulation model. And of course, to determine the type of computer, the strength of computer that you need to run this simulation model. Here, you want to also determine the number of active and number of inactive cells that you have in your simulation model. Sometimes you even want to turn off or turn some of the cells inactive, okay, to help you with a faster simulation run. So if you have some cells that don't really affect your hydrocarbon volume, I mean, where you don't have oil saturation or hydrocarbon saturation, you might just cut them off so that you can focus on only the cells where you have hydrocarbon. Yeah, you also want to determine or find out your vertical permeability, because most of the times this is not modeled in by the geologist. So it's the job of the reservoir engineer to determine the vertical permeability that you are going to set for your model. Okay, we're going to talk more about this when we move on to the Eclipse interface, which I want to quickly go over these slides so that we can focus on the process of using Eclipse. And then you have one more set of data here, which is also very important. And we have what we call the initial data. The initial data basically is coupling all of the initial properties of the reservoir or the data that we have talked about earlier into your model, and you go on to perform your first simulation run, okay? Yeah, so let me leave this one for now so that we can quickly go into the Eclipse interface. So this is the Eclipse interface. I'll minimize it one more time so that I'll show you how to get to that point, okay? So when you start your Eclipse launcher, basically this is what you're going to find. This is the simulation launcher. And then from this simulation launcher, you see on the left-hand side here, there are different sections on this column. So you have the first box here, which is telling you the simulators that you have installed on your computer, okay? So in this case, I have Eclipse, I have E300. Sometimes you get to hear E100, E300, and this kind of stuff. So this Eclipse here is E100, but it is generally called Eclipse. And then you have the E300, which is also Eclipse, but it performs a different type of simulation run. It's called a compositional simulator, okay? And then the E100 is called a black oil simulator. Most of the simulation that you are going to be running, or let's say at this basic stage, will
Hello,
be...
sorry,
Hello,
sir.
sorry, Mr. Joseph.
Okay,
Your screen is not showing.
my screen is not showing.
Yes.
Yeah, please.
Oh, okay.
It's just the slide that is showing. So you have
Okay,
to.
okay. I understand now. I understand now. I think, can you see it now?
Yes, sir.
Oh, okay, okay. Thank you. Okay, so I was talking about this first column here on the left-hand side, and you have the first box on the column, which is named simulators. So I was talking about different types of simulators that I have installed on my own computer. So I have Eclipse, that is also referred to as E100. I have E300, and I have FrontSim. So I was trying to tell you the difference between E100 and E300. E100, also referred to as Eclipse, basically, is a black oil simulator. And then you have E300, which is a compositional simulator. Now, let me not waste time for now going to talk about what each of the simulator does, but most of the simulation that you are probably going to be running, especially at this time, will be black oil simulations, and E100 will do just fine. It will be enough for you. So yeah, Eclipse E100, that's what we're going to be making use of in this meeting. And then down here, you have Eclipse pre and post processors. So the apps or the tools that you have in this category helps you to perform some tasks either before your simulation run or after your simulation run. Now, an example of the type of task that you might have to perform before your simulation run is data entry. All the data that are going to be used to describe your reservoir model are going to be entered with a preprocessor. So an example of a preprocessor is this Eclipse Office, which we are going to be making use of. Another preprocessor is the PVTI, and then you have the SCAL and all of that. Now, the other one that is called the postprocessor are the tools that you need, that you work with after your simulation run has been performed, all right? Now, after you run your simulation, you want to view results. Either you want to view your results in a chart form or in a grid form, okay? Whichever way you want to view it, you have to make use of the post processor, all right? So that's what you have in this category. And then down here, you have manuals, and you can also link your Petrel to your Eclipse, of course. In fact, if you have more than one simulator installed on your computer, like in a case of where you have Intersect, there is another simulator, almost like Eclipse, but a more powerful simulator that is called Intersect. If you have it installed, it's also going to show here, okay? So those kind of stuff. Now, we're going to be making use of E100, like I said earlier, to run the simulations. But before we go on to that, I want us to quickly go here, the Eclipse Office interface. So that is like the one of the easiest ways of entering reservoir data to build a simulation model. You have other methods as well. You can use Petrel, the one we call Petrel RE. Okay, you can use Petrel RE to describe your simulation model. I want to start that to show you as well. So you want to use Petrel, you can use Petrel RE to build the simulation model. You can use Eclipse Office, or you can simply go on to use data file. Okay. So the data file, which I'm going to show you later, is like writing some codes. Okay, writing some codes to describe your reservoir. Okay, and after you finish writing this code, you submit it to the simulator to perform your simulation run. So whichever one is that you are comfortable with is fine. But writing the data file is like one of the tedious ways of doing it. I mean, you need to have a very good understanding of reservoir simulation and Eclipse itself for you to be able to use data file. I'm going to show you a data file. We're going to make use of Eclipse. All right. Once you select the application that you want from here, either a preprocessor or a postprocessor. Once you select it, of course, it's going to be bold to show you that this particular application is selected. You come down here to click on the Run button. So immediately you click on the Run button, you see the Eclipse Office pops up, and that is what you have here. Okay. Now, those processors, preprocessors, postprocessors can also be found directly from the Eclipse Office. You can launch them directly from here as well. Okay. So the first thing you want to do here, is to create a new project. You know, the same way you create a new project when you want to use maybe the Microsoft Excel or a Microsoft Word application, you create a new project. So you create a new project by coming to File and New, and then you're going to give it a name. Okay. I don't know what name you want to give it, but I have something created already, but I'm going to create one more here. Okay, I'll create it in this folder. Now, before creating a new project, it's always a good practice to create a dedicated folder, a folder dedicated for your project. And I'll tell you why you want to do that. When you run an Eclipse simulation, it usually generates a lot of files as results. Okay. Sometimes you have 1,000 files, and you want all of these files to be kept together neatly. Imagine 1,000 files spreading all over your desktop, or imagine 1,000 files in your document folder, and you have them mixed with maybe your CV or any other information. I mean, you're just going to give yourself some kind of extra work sorting out files. But when you create a folder to house all of those files, then all you just need to locate a particular file is to go into that project folder, and everything is there. Okay. So before you start, you want to create a folder, which I am going to do right now. I can click on this button here, and the folder will be created, or just right click on wherever you want to save it, and you go and create a new folder. So I'll name it Petal +1, right? And then inside the folder, you can now create your project by giving it a name. Let's say I call this exercise 1 again, okay? But let me just say exercise 1 so that I don't begin to add unnecessary characters. By the way, giving names to your project has a few rules here and there. So the very simple one I'm going to share with you right now is that you don't include space in naming your project. You don't include space, okay? So sometimes if you type some characters, it might conflict with other characters that are found in your data file. I'm going to show you the data file shortly. But for now, let's just create a project, exercise 1. And the way you recognize an Eclipse project is by its extension. By the way, you have a whole lot of extensions when it comes to working with Eclipse, a whole lot of different file extensions. So the first one I'm going to share with you right now is the .off. So if I create this project now, exercise 1, it's going to be named exercise 1.off, and that tells you that it's an Eclipse Office file, all right? So I'll click on open, and then we'll have this folder created, exercise 1. This is the name of the project that we are going to be working with. Okay, before we go on, let me quickly go into the folder where, can you see the folder, or do I need to share it separately? Can you see the folder?
Yes, we can see the folder.
Okay, did you see it when I shared it, or you saw it earlier? I don't know. I'm not so used to Zoom. Okay, so so here is the folder that was created where our project is going to be stored. It's going to be stored here. Okay. So one moment, please. Okay, so our project is going to be stored here. And it looks like the folder is empty at the moment, and that is simply because we haven't saved the project. So I can simply go back to the Eclipse Office. Can you see Eclipse Office now, or I need to share it?
You need to share it. We can see it.
Okay. Okay. Is there no way to share everything?
Yes, it depends on the screen sharing option you choose, sir. You choose the one that has to do with your screen.
Oh, okay.
Yeah.
So
when you
you can share your screen and everything shows.
Yeah.
Okay, so where do I share that? Okay, portion of the screen. Okay, it's fine. Let me just go on with this for now.
Okay, sir.
Yeah, let me just go on with this for now. Okay, so you can see my Eclipse right now, right?
Yes, sir. Yes, sir.
Okay. So if I go on and just say save project, now the project has been saved. So if I go back into that folder, so you can see this is the project that we saved. Can you all see the exercise 1.off? Now at this point, this is the only file in this folder because we have not added any other data. So we'll now begin to add data to this simulation project, okay? So the data we're going to be adding are those information that describe our reservoir model, okay? So we talked about those information earlier. We talked about the grid and the grid properties. We talked about relative permeability and PVT, pressure data, and so on. So we want to go on to add all of those things now. So there are two different methods you can use to add those information to your Eclipse Office project. If you have okay, the first
So I think your sound is off. We can't hear.
Please let's exercise patience. It should be network. He's unmuted.
Am I back? Hello, everyone. Can you hear me? Am I back?
Yes,
Yes, sir,
you're back. You're back. We can hear you.
Okay, that's fine. That's fine. I'm having a network downtime here. Okay, so you can be out because have enough to this. So that is the wrong button, the data that you can add to your simulation project. Okay, we have case definition, the grid, the purity, and all of those stuff. Each of this data section is called a data section. So each of these buttons here represents a data section.
Hello, Mr. Joseph.
I can hear you. Go on.
The pop-up button is not showing, so it's not shared, so we can't see.
Will someone not teach me how to share this thing now? Someone should teach me. Where do I go to do that? So I need to be sharing everything. Okay, show all windows. Okay.
Always does everything. So show always, so it shares everything.
Okay, what can you see on my screen now? What can you see?
Yeah, we can see the license selection where you get to see the core license profile.
Okay, good. That means I'm sharing everything now. Okay, that's Petra. Okay.
Yeah, beautiful.
So, okay, good. Screen showing on stop as the window is closed, really? But you can still see my screen, right? Can you see the data manager now?
No, nothing is shared. We can't even see the screen. Nothing at all.
We can't even see the screen. Wow. Okay, one moment. I'm sorry, I'm not so used to I am not so used to this one.
You can start sharing again, but this time share the whole window so we can see everything. not just your presentation slide.
Okay. Now I'm not even seeing any share button. Share button
Okay.
is gone. Okay. Multiple participant advanced sharing options.
Okay, sir. When you click a share screen, the very first window that appears should be your desktop window. So just share that one, sir.
That's the one I've been sharing. That's the one I've been sharing. Can you see my screen now?
Yes, sir. Perfect.
Yeah, that's the one I've been sharing. I just don't know why. Yeah, that's the one I've been sharing. Okay.
Sometimes it
So,
malfunctions.
okay, so I'll close this now. I'll go back again. I click on this button here, the data button, and then this dialog box pops up. And then from this dialog box, which is called the data manager, by the way, it has all of these sections. Each of them is referred to as a data section for your simulation model. Okay, so the first one here is called case definition. This is where you do the basic settings for your simulation model. Now, the first thing you want to do here is to select the type of simulator that you want to use. This is black oil, which is called E100 or simply Eclipse. Now, this is compositional, which is E300, and then you have this other one, the thermal simulator, front sim, and all of that. So like I said earlier, black oil is just enough for whatever you want to do at this point. So if you have a title for your simulation model, you want to add a title. If you have a production history data, you want to pick the first date. I mean, the date where you have your first oil in your production history data, you want to add it here, all right? And if you don't have a production history data, like in the case of what we have here, you can put any date. You can put today's date. You can put January 1, 2021, as the case may be. So let's just use these dates, okay? Of course, I'm not going to save this. I'll cancel it. And then once you are done here, okay, here you are also going to select your model dimension. What type of, what size of model do you want to work with? Yeah, but I'm going to leave everything blank for now. I'll tell you why. But let's just go through, let's walk through all of this. So you can go to the next tab, which is called the reservoir tab, where you can select whether you want to add aquifer to your model, whether you have a fracture type of reservoir. You can select your grid option if you are entering this information here all by yourself. Then the PVT tab, you have the options to select the type of fluid you have in your reservoir. Oil, water, gas, maybe dissolved gas or vaporized oil, as the case may be. Do you want to perform API tracking? There are a whole lot of options that you can pick from here, okay? And then once you are done selecting all of this information, you simply come down here and hit the apply button. And once you do that, it's going to save all of this information, okay? And once it is saved, that way, if you come to this folder, can you see this folder now? I want to know if I've done the correct thing.
Yeah, we can see it here.
Okay, so I'm sharing everything now. So once you click on the save, you can now come here and then you're going to find those data you have added here. Okay, I'll go back and then, like I said, I am not saving anything. So I'll simply go on to cancel what I have here. Yeah, do you want to cancel it? Yes. So that's the case definition section, and then you have all of these other sections here. Now, the next one may not be available to you because you haven't described a case here. Okay. Now I'm going to close this data manager for a moment. We are coming back. I want to show you the other option you have to bring in data into your simulation model. Okay, you can import this data if you already have them. Now, if you come here to case, all right, and then you come here and you click on import, then you'll be able to import a data file if you have a data that has been created already. And for instance, if I go to, if I come here, okay, do I have that? Yeah. If I come into this folder and I open this other folder named class 2, for example, okay, then you see I have some data file, I mean, a simulation model that has been created before. So once you find the file, which is it's called a data file. We're going to the data file shortly. So if I click on it and I click on open, again, take notice of its own file extension. We talked about the .off file extension earlier. What we have here now is .data, D-A-T-A. It's another type of file, okay? So if I click on this and I click on the open button, then you give Eclipse a few seconds to allow it to bring in all the data into the software. So if I go back now to the case definition section, which is here, you see? So on case definition, you now see all of these things have been populated. So we now have a model dimension. So we have a 67 by 49 by 20. What it is saying is this. First of all, when we talk about a dynamic reservoir simulation, most of the times we're referring to a 3D reservoir model. So what we have here is the dimension of a 3D object or a 3D model, right? So you can see we have the X direction, the Y direction, and the Z direction, okay? So along the X direction, you have 67 cells. Along the Y direction, you have 49 cells, and then vertically, you have 20 cells, which means that in your reservoir, you have 20 geological layers, okay? So that is what this information we have here is basically telling us. So if you come to reservoir, okay, some other information has been selected here. You do not notice for now, but here it is more notable. We can see that we have water, oil, gas, and dissolved gas selected, okay? Now, for SCAL, we have endpoint scaling selected. We're going to talk about what all of those things mean. And basically, I think that's it. All right, that's it for now. So I am going to close this since I did not change anything. You can now come here to the grid section. So when you come to the grid section, this is what you see. This is the grid section data manager. To view anything here, okay, you have a couple of options. You can just come here and run simulation for you to be able to view what the grid looks like, but let's leave that one again for now. I'll talk about how to view those things later. So let's just come to subsection. Please take note of this step. You need it. So let's just come to subsection, and then you have grid keywords. Now, if I go on to click on grid keywords, you now begin to see all the information that describe your grid. Where is it? Okay, I'll just go back there again. So you now have all the information that describe your grid. So you have the grid properties, which include the permeability and porosity. permeability in the X direction, XX permeability, permeability in the Y direction, YY permeability, and then of course, permeability in the Z direction. And here you have porosity. Now, let me draw your attention again to one more thing. If I click on the XX permeability, for example, and you come to this part, you see Perm X. That tells you that, you know, I said something earlier that you can use a notepad to create a data file for your simulation. And that way you have to be entering some form of codes. Those codes are called Eclipse keywords. So for permeability in the X direction, the keyword for it is PermX.